Hey everyone, in this video I'm going to go through the rest of the main animation graph and its linked layers in Lyra's main animation blueprint, which handle the montage slots, applying additives, handling IK, all that kind of stuff, which will just leave the control rig that is being used for some foot stuff to be covered in what will be the next and final video in the series. Let's get started. Alright everyone, I'm inside of the mannequin base animation blueprint, and I'm just going to work my way from top down to bottom through this whole graph and explain everything that I am able to. Unfortunately, this left-hand pose override state is something that I was not able to figure out in time before I wanted to make and get this video out, but I will go ahead and go through it, even though there will be aspects of it I will not be able to explain properly. And I'd really appreciate it if any of you guys do understand exactly what purpose it serves in the system, I guess. Definitely leave a comment and I'll do a little follow-up video where I explain what I can to the rest of the viewers on the channel. So, after the locomotion state machine, we have the output locomotion pose, and that goes into this left-hand pose override state animation layer. We can find this anim layer in the item anim layers base animation blueprint. Here it is. You can navigate to it yourself from the item anim layers section over here, and it takes an input pose, which is a bit different than the previous ones, and I'll go ahead and show you where that is set. It's in the item anim layers animation layer interface. If we find the left-hand pose override state here, we can see that there's an input pose set as an input. So that in pose is going into a layered blend per bone node, which is using a left fingers mask. And this node, whenever it updates, it's calling this function here, set left-hand pose override weight, which is reading from a boolean, which is a setting, so it's not being set anywhere by code. It's something you have to set depending on whether or not you want the left-hand pose to be overridden or not. And so we're selecting a float, either 0 or 1, based on the state of this boolean, and then we're subtracting a disable left-hand pose override curve. So if there is an animation that's disabling a left-hand pose override, we're subtracting that, setting this back to 0. We're clamping this between 0 and 1, so that if this is turned off, and we have an animation with the curve, we don't put out a -1. So then we set the left-hand pose override weight, which is being plugged into the blend weight for this layered blend per bone node. And then we have a sequence evaluator that takes a sequence input, and the explicit time is set to 0, so it evaluates the first frame of an animation, whatever is set to this variable, and it blends that into the left-hand fingers for that bone, if the setting is set to true and if the animation doesn't have a curve disabling the left-hand pose override. I looked through some of the animation layers, which can be found, the animation layer blueprints, which can be found in the different animation set files. So if we let's go to Pistol, we have a child blueprint of item anim layers base that I can open up, and it's left empty. It inherits everything from item anim layers base, and this is where all the animation sets and settings can be set. So here we have all the animation sets for idle. And it looks like there is no left-hand pose override, so I may be in the incorrect animation blueprints here. So let's go over to Shotgun. Here we go. So the left-hand pose override is a shotgun idle hipfire pose. So this seems to be overriding the base pose of whatever animation is playing, so that the left hand remains on the weapon. So what this means is that the left hand pose is being overridden whenever it needs to be overridden, so that it always stays on the weapon if some animation plays that might move it away from the weapon. so while the weapon is out. Exactly where it comes into play, I did not have time to exactly figure out, and in my brief testing earlier, I was unable to see any changes toggling the boolean on and off. So that's that, and that's the part of this that I was not able to figure out in time. I'm going to close out of all of this, and I'm going to come back into the main animation blueprint. So after this override state, we save a cached pose named Locomotion. We then use that pose with an apply additive node, and we blend based on an upper body dynamic additive weight float. We take in an additive identity pose and an upper body additive slot. So what I believe the additive identity pose is with, I was not able to find any documentation on it, and if you just hold Control-Alt for more information, it just says that it returns an identity pose. So what I believe this does is if you have an additive animation, you can give it a base pose that it applies the additive to. So let's say you have a, let's say you have a character that wields a sword, and they have a base stance where they're holding that sword, and you want the character to be able to swing the sword while they're walking around. Well, you could have a sword swing animation that applies to the full body, but is just the character in that idle pose. They don't take a step or anything while they swing the sword. You could set that animation to be an additive animation, and set that base sword pose to be the identity pose inside of that animation settings. And then then you could play that animation as an additive over that base pose. And what this node does is it gets I believe it gets that identity pose for whatever additive animation is being played, so that things don't ever turn out weird if you're in the incorrect pose for the additive. Because now we're blending this in, or applying the additive based on this float here. And this node just ensures that the additive is always being applied to the base pose it's supposed to be applied to. This slot here, I should mention, is a montage slot, meaning that if you give a montage, tell it to use a certain slot, such as upper body additive, this is where the montage will play in the animation graph. Now the upper body dynamic additive weight float, let's look and see where that's set. I'll just search upper dynamic, that should pull it up. Yep, here we go. Set upper body dynamic additive weight, which is inside the update blend weight data function, which can be found in blueprint thread safe update animation right here. And so it's selecting a float based on, so if any montage is playing and we're on the ground, it's going to pick A and set upper body dynamic additive weight to 1. If that's false, it's going to interpolate upper body dynamic additive weight to 0 with an interpolation speed of 6. So after that, we go into a layered blend per bone, where we then blend in this upper body slot, and if we have a montage playing on the upper body, we override any upper body additive montage. This output is then put into a full body pre-aim slot, so whatever pose is output from here, any additive pre-aim montage for the full body is going to be layered on top of that pose. And then we save a new cached pose, use it down here, and we put that into a full body aiming linked anim layer, which I'll come back to in a moment. We then go into an additive hit react, so on top of all of this, we play an additive hit react montage. If that gets played at this point, we apply a full body additives animation layer, which we'll look at. Then finally, after all of this, we'll play a full body montage slot, and this will override, if a montage plays here, it'll override all of this other stuff. Finally, we go through an inertialization node, which allows us to use inertial blends in the state machines. Rotate the root bone for turn in place, and then we get into the IK stuff. So there's a lot of montage slots here, and this setup here, I'd say, is not a setup you'd need to worry about trying to copy exactly for your game. This kind of setup, the montage slots, the additives, how they're applied, it's very flexible. Your best bet would be to achieve a basic understanding of what the different nodes do, and then build out your own system that meets whatever your game, the needs of your own game. You don't need to do this much, you might need to do more than it. It just depends on what your objective is. So, after this upper body, lower body split pose, well, from it, we go into a full body aiming linked anim layer. So let's take a look at that. Going back into item anim layers base. And I'm looking for full body aiming. Here it is. So this one takes it an input pose, an aim yaw, and an aim pitch. It saves the cached pose for the input pose, named base pose. We then use two aim offsets for a relaxed aim and an idle aim sequence, or blend space, I mean. Let me blend based on this aim offset blend weight, and that goes into an output pose. So let's look at both of these. So I'm just going to go back into this base folder and I'm going to search relaxed. Nothing's coming up. So is this a variable? It may be. I may have misread that. Yes, it is. So let's head over into, let's do the rifle layer. So animations, locomotion, rifle anim layers. Let's search up relaxed. And here we go. So it's just using an unarmed. It's going to have a rifle holding additive applied, or that's going to become the new base pose for this. One of those two. And this is for when you're not aiming, so you're just holding the rifle at your chest or waist level and looking around. And then the idle is when you're holding the rifle up and actively aiming. And that's the difference between those two. And so we're deciding which one to blend between based on this aim offset blend weight. So let's find that variable. Aim offset blend should pull it up. Yep. Open up that, and it brings us to this update blend weight data function that I covered in a previous video. So essentially, we have a couple of branches here, and we're just determining through these booleans the state of the character. So if this is false, meaning so we're not crouching, and raised weapon after firing when, so if we're crouching, and raised weapon after firing when crouched is not true, we are going to go off of the true branch here, which we're not going to focus on right now. But if these are false, and if we are not aiming down our sights, and we are not on the ground, and this is going to be false. So if we're not on the ground and we're not aiming down our sights, we're going to come off of here. So if this is true, meaning we're on the ground, so if we're on the ground and we're aiming down our sights, or we're crouching, and raise weapon after firing when crouched is not true, we're going to set this aim this aim offset blend weight to 1. But if we're in the air and we are not aiming down our sights, we're going to come to this next branch. And it's going to do more logic here. I'll try to go through it relatively quickly. We get the time since we fired our weapon, and if that's less than a certain threshold, we set our aim offset blend weight to 1. Or if we are aiming down our sights and we are crouching and we're not on the ground, or we are not on the ground, we set our aim offset blend weight to 1. So if we're aiming, or if we are crouching and not on the ground, we set that to 1. Or if apply hipfire override pose is greater than 0, which is an animation curve, we set the aim offset blend weight to 1. But if that is all that is false, or then we set the aim offset blend weight to 0 through all this interpolation stuff here. Or, and this is pretty complex, we set it to 1 because we want to use aim offsets when we're idle or we have root yaw offset. So if we are looking around and using a root yaw offset, we want to make sure we're still aiming with where the camera is pointing. So coming back to here, where are we? Yep. And so if it's set to 0, it's relaxed. If it's set to 1, it's idle. And that is given into the output pose. There, that is sent over into the output pose. Next, we have the next linked layer is a FullBodyAdditives Layer. So back into item anim layers based. I meant base. So we have a FullBodyAdditives state machine inside of this layer. So we have the state machine here. There's nothing inside identity or air identity, but there is something inside of land recovery. So my best guess is these states are used to determine when we are on the land and recovering. And then we take in the additive identity pose, a sequence player for a jump recovery additive, and then we use this land recovery alpha. And when this becomes relevant, we call the land recovery start function, which will set the land recovery alpha based on the time falling and whether or not we're crouching. So we take in the time falling between 0 and 0.4 and map that to a range of 0.1 to 1. And if we're crouching, we half that and set a land recovery alpha. And we use that to blend into this jump recovery additive state. So the higher up you were jumping, the longer, the longer you were falling. So yeah, the higher up you were, the longer you were falling, the more this jump recovery additive is played, which is going to compress down the player as they land. And then we just have the transitions. So if we're not on the ground, we go into the air identity pose. If we are on the ground after that, we go into land recovery. So if we're not on the ground, we go back into this. Or if, and this seems to be an automatic roll, so, or if this land recovery sequence is done playing, we also go back into this. Then we'll go back through once we jump again. And that is what full body additives are being used for in Lyra. So it's just applying an additive when you land from a jump. And that finally brings us to the procedural fix-up and IK stuff. So I'm going to cover the final layer in this video to end things out, but I'm going to keep the control rig here for the next and final video in this series. So, full body skeletal controls. This is where we will find the standard IK stuff that you see in lots of animation blueprints. So we do a hand IK retargeting, which handles the retargeting of the IK bone chain and moves the IK bone chain to meet the FK hand bones based on the FK hand weight input, which will favor either side, where 0 is the left hand, 1 is the right hand, 0.5 is equal weight. So, and the alpha curve name for this is Disable Hand IK Retargeting, which some animations will have. So let's search up hand FK weight. And so, looks like this is a setting. It's not being set anywhere, and it's set to 1, so it's going to favor the left hand. I'm sorry, the right hand. So it's going to take the right hand and move the IK chain to meet the FK bone chain before it does anything else. Now it's going to copy bone. We're going into a copy bone node. And the copy bone, I'm going to read this explanation here. The copy bone control copies the transform data or any component of it, example, translation, rotation, or scale, from one bone to another. And it's copying the virtual bone IK hand L weapon space to IK hand L, so it's taking this virtual bone and moving the left hand IK bone to it. Now we are transforming the root bone by -20 based on whether or not we want to disable the control rig, which I find interesting. My best guess as to what this is doing, and I don't fully understand it, because you could just blend it in and out of the control rig. This seems a bit convoluted to me, but by -20, right, that is -2. So you're just lowering the root bone. I'm not too sure why they're doing this, to be honest with you guys, and I apologize for that. It seems to be a roundabout way of disabling the control rig, when you could just do a blend based on the boolean. And that's the approach I personally would take. But that they're lowering this by -2, my guess is that because the root's not in the ground, it breaks the control rig somehow. I honestly don't really know. It confuses me why they took this approach. Now we're doing basic 2-bone IK, moving the FK bones to meet the IK bones. So with a joint target being set, but an effector location being set to 0. So we're just moving FK to IK, as would be standard. So if you want to move where the hands are at, you move the IK bones somewhere else, and the FK bones will follow. Leg IK 2. So just making sure the feet follow the leg IK bones. So if you move those at any point, they get moved to follow. And then we have this transform modify bone, which modifies the weapon right bone to scale down the weapon during the equips, or, well, yep. And then we just have scale down weapon right as a curve name. And then we have the scale set here. And that's it for the full body skeletal controls layer. And this again is this kind of thing you change up depending on what your approach is, what you are trying to do. Very modular. They're just using the nodes they needed to achieve the functionality that they needed for their specific system. And you can use Lyra's Locomotion very much without any of that IK stuff, and build out your own IK separately, or use their, or base your IK system on their IK. And that would finally bring us to the control rig, which I'll go ahead and show you guys how big it is. It's really big. Okay, it didn't look big there, but then I scrolled out more, and now, yeah, this is why. There's a lot of stuff going on here. So I'm going to look into it some more, try to get a really good understanding of everything that's going on, and cover it in a subsequent video. Alright, so I hope you enjoyed the video. If you did, be sure to leave a like and subscribe to the channel. The final video in this series is coming, and I'll be posting more videos on a weekly basis on the channel after that. But I'm hoping to fairly soon actually start a new series on where we build a locomotion system from scratch with many similarities to the Lyra system. There's no use in reinventing the wheel, but I'll also be adding some new things to it, some of my own things, and explaining individual concepts that are being used to build up a larger system in more detail. I'm really looking forward to getting started on this series. It'll essentially be the old Unreal Engine 4 Distance Matching Series 2.0 revamped, done better for Unreal Engine 5. So I'll hope to see you guys there. Whenever I do get it started, it will be multiple weeks because I'm still working on building the system. Anyway, I've rambled on long enough for the outro, so thanks for watching, and I'll see you all in the next video.